Hello, Ryan Mohammed here. Again, homework 2. Um, Thought it might be easier just making a video again, but I'm gonna try to keep this one under 30 minutes this time. But just to start off, running my own container just because some problems I had with Azure Data Studio and my connection to the um, class database. I'm just running the backup here just for consistency. Um, but yeah, jumping right into it. Uh, yeah, here we have all my propositions and stuff like that, just to kind of get this point out the way. Everything here is the converted north wind, so just gonna point that out at the start, but it's pretty much all of them. Just gonna go all the way down here, all the way down to 20, so it's pretty much all these queries. I think just some of them I didn't have permissions to actually implement them, like this guy right here, so that's just why it's not over here. Um, I think I was trying this when I was still connected to the class database, so maybe I could give that a shot with my container. But yeah, these are just all my propositions. I won't spend too much time on this just because whenever I have this notebook open, my computer starts to kind of freak out. So I'm just going to try to skim through these. Some of these starter ones, I'm just going to kind of skip past these just because these are a little bit simpler. I think I'll jump right up to 10. Or maybe even a little bit before that, maybe just somewhere in the middle relatively. um, but yeah, so this query right here, I think the eighth query, it's a non-equal join, so that just means we're not using an equal operator in our on clause, that condition that kind of combines these tables, or at least uh, the rows from the tables. uh, But yeah, this is just a non-equal join, just kind of pointing out this could be greater than equal to. Well, that's not non-equally then if it's greater than or equal to, because it could still be equally. Yeah, so I guess that's wrong. So only these guys, greater than, less than, not. But moving on. This guy right here just retrieves all the order details with the respective customer details and order ID. So this is actually a composite join with more than 2 tables. I don't know if that's the right name for it. Maybe a multi-join. I think that's one where there's different types of joins. But here we're combining tables, right? The customer table and the order table, and we're combining them where the customer ID equals the customer ID from the order table. So we're just grabbing the customer and its relative order, right? And they're linked via that customer ID. Right, so that's how this inner join combines them. And so as our SQL runs, first performs this one and it creates this table using that inner join, right? So we can just imagine a whole brand new table right there. And then this one executes by combining that table, which we have right there, with another one, right? So that other table is the order detail table, right? So we're joining these, right? We're getting the shared rows, at least from both of them, right? Where the order table, or at least the order ID that comes from the order table, matches the order ID that comes from the order detail table, right? So we're just getting the customer, its respective order, and the order ID associated, or the order details associated with that order ID. Right, and we're just selecting those specific columns, and here we can see here, why did I click run? Sorry about that. Oh man, yep, I told you. um, but yeah, that's pretty much all that does. Just moving on, I probably won't stay here too long, just to conserve time. And you may notice a little bit better quality, slightly better. Customer and their order. So this just returns the customer and their orders, including customers with no orders. So this is a big part right here, no orders. So what this left outer join is similar to inner join, or at least well, it's not technically similar to inner join. Well, it has aspects of inner join in it, if you will. So it gives us back everything that's shared between customer and order. But if customer does not share anything with order, we still receive it. But the columns that we select from order, they'll be null, right? So if it doesn't share, so that kind of, it takes everything that they share and everything from customer, but with those null values for those columns that come over. So a big part about that left outer join, or all outer joins in general. But we see here, we see those two. Those I think I left off by hitting this just to see if it actually worked. But yeah, just like in class, this 22 and 57 is null. So no orders from those. Right, so it gives us back everything. So we could see the slight difference between this and the last query where we get 832 versus 830. Yeah, I think I'll skip that one for now because it falls along the same lines. This is just only them. This one was an interesting one. Had to run through it a little bit, but let's try to explain it a little bit. So this generates all numbers between, or this is actually wrong, all dates. Yeah, you can't see a ton of lag. All dates between January 1st, 2014 and December 31st, 2016. So the way this does this, right, is first basically what's going on here is, well, not in the parser, but in terms of a lot, let's start down here. So basically, the nums table, it's 0 through 9 once again, right? Well, actually, this is not 0 through 9. That's the digits table. The nums table is 1 through a very large number. Let's say 10,000. I might be wrong. But many, many numbers. But what we're doing is we're kind of going through each of those numbers, right? So let's first look up over here at this kind of piece of code. So what this does is it goes through all those numbers, maybe like let's say 0 through 10,000 or something like that, right? And for each number n, right? So that's kind of what all those numbers are called inside that column n, right? So for each number n, what we're gonna do, right? So 0, 1, 2, etc., etc., right? We're gonna use this built-in function date add, and we're gonna add in terms of days. So that's kind of our interval. We're not going by months. We're not going by years. We're going by days, right? We're gonna add 0 to the day, 1 to the day, 2 to the day, etc., right? And we're gonna start off at this date right here, right? So this is our starting date, 2014, January 1st, and we're just converting that to a date to use in this built-in function right here, right? So what this does, so let's say if it really was 10,000 numbers in there, this would generate all the numbers starting, or all the dates starting here, all 10,000 dates starting here and after then, right? So maybe what's 365 divided by 10,000? Not too sure. Maybe like at least 100, right? No. Okay. But anyways, what we're doing is this will return us a lot of dates, exceeding this for sure. So what we're doing is we're just restricting it to where n, like let's say the number of days that we're adding to this, right? So it could be a week and that would be 0108, or it could be 365 and then this could be 2015 0101, right? So that's what n would be over here. We're just checking where that number is smaller than the difference between these two dates, right? So this may be, let's say, so this is about 2 years, right? Or 3 years. So that'll be about 1,000 days, right? So we're just going through, we just want the dates in between this. It's just kind of a cool way to do it, right? Where we're using n to figure it out, right? To kind of offset from the starting date, right? So this gives us back a number like 1,000, right? designate the days in between these two points, and then this just checks if the offset used is less than that to see if we're in between that. And this right here is just for that inclusiveness. But I think I'm gonna hold off on explaining all of these just to show you we got it here. Oh, and this once again uses GitHub. I have all my files right here. They're all on GitHub already. All my queries. Probably didn't need to do that since I'm recording the video, but better be safe than sorry. But yeah, I think that's enough of just the propositions. So, okay, sure. Well, let's jump right over here. So this one was pretty fun. Let's start from the top. And let me close this just to speed things up. Man, yeah, it got some big queries here. Yeah, like 7,000. Okay. Anyways, so I may not explain all of them, but yeah, I think we'll start with probably. Yeah, we'll jump probably to each other one. So write a query that generates 5 copies out of each employee row. So immediately I thought cross product, right, multiplying, right? So kind of implemented that digits table, I believe. Oh no, this is probably a bad choice. I probably should have gone with digits. But yeah, it kind of just does the Cartesian cross product of the nums table and the employees table. So for every number, we get 9 employees. So let's say 1 through 10, but you get 1 through 9 employees 10 times, right? So I'd have a table of 90 employees. Don't know why this jumped down, but yeah. So that's pretty much all this part does. I'm just being selective with those columns I get back. And once again, using aliasing here in the select clause and in the from clause. I found this from clause aliasing pretty cool, because once you do it here, you could use it everywhere else because of that parsing setup. But yeah, that's pretty cool. But here, definitely didn't want all. It's probably the many rows I was probably gonna get by using nums. So filtering it out using where. But I may skip 1.2. So yeah. Oh yeah, let's talk about this one. So write a query that returns a row for each employee and day in the range June 12, 2016. So here, definitely reading this chapter really helped, because first thing I thought about doing was first generating these days or something like that, because these days may exist. These days certainly exist, right? But oh, actually, yeah, that's the wrong way to put it. These two things have no relation to each other. We're not getting these dates from any table or anything like that, right? So we wanna generate it somehow, right? So, and we're just gonna generate it and then combine it with employee, right? So the way we generate it is kind of along the same lines as one of those examples I was explaining earlier, but using the nums. I probably should. Okay, nums is probably a good idea here. But here I'm just taking in that start date, right? And for each number in nums, I'm just calculating the respective day after that. So if there are 10,000 days, I would get the day 10,000 days after this date, right? But just to kind of ignore this for a little second, and then I'm just kind of, just for good practice, I could have just done like less than this guy right here. But just to get used to date difference, decided to use this guy, and just to keep it inclusive, square bracket this square bracket, just using that date difference function. So I'm just checking if the offset used is less than or equal to the difference between these two dates. So the difference is probably, like, let's say like 4 or 5, right? If it was 6, if 6 was the offset and I generated 18, 18 or 17. I'm bad at math, but it wouldn't come back. Right. So what the cross join does though is it gets me the Cartesian product, right? Because what this guy does, what I just showed you, this gives me these guys. It would just give me back 1, 2, 3, 4, 5, right? Just 5 of those. But what I want is to get kind of the Cartesian cross product of this guy and each employee, right? So each employee has a row associated with each one of those dates, etc. Right? So that's why I'm doing the cross join right there, and I'm just ordering first by employee ID and using this as a tiebreaker, just to keep it exactly the same as that desired output. Let's see if we could jump a little ahead. I'll briefly show these just in case I don't explain it. You could always look at them. Return US customer. For each customer, the total number of orders and total quantities. Oh, so this is actually probably a good one to explain because this one had me stumped. One of the few that had me stumped on this homework. Return US customers, and for each customer, the total number of orders and total quantities. So yeah, I ran into a couple little errors here, but definitely helped me out a lot. So the first thing I thought about doing here was first retrieving the customers in the USA. So that was pretty easy. All that took was this line right here. From that customer table, select the customer ID, where the country is the USA. Not too bad. But the next part that started to really challenge me. So here I was kind of messing around with the different examples shown in the chapter, like using parentheses in different order. I just thought, just to be safe, I'd use the left outer join just to include customers in the USA who may have not ordered anything yet, even though the question didn't really say that. Just to be safe, I use that left outer join. But yeah, so this was giving me good stuff. I was just testing around with it. And what really stumped me was this guy right here. I was using sum, and this was totally fine because it's an aggregate, right? For each of these customer IDs, right, I'm just summing the quantity of the quantity associated with them, right? So what this guy does is it combines the customer table, the order table, and the order detail table when they have that link, right? When the customer is linked to that order via the customer ID, right? So that gives me this new table of customer and order. And then what this inner join does, so remember the way it executes is this first makes the table, then that table is input to this inner join. So we have that table, and we have another table, right? And these two we're combining these with one of those shared properties, order ID, right? So we got the customer, his order, his or her order, and the order details for that order ID, right? But I ran into problems for sure, and I spent a lot of time thinking about it because technically I had duplicates because of this, and I was wondering if I should reorder it in a way, or if there's a way to get it where I don't get any duplicates, but I also still get the information I need, like quantity. But couldn't really figure that out until I really took a look at what was going on, and I just started counting the order ID. I was getting 22, and that was double the expected output. But just realized it was getting double because I'm doing this second inner join, right? So they're double the rows, right? Still a little bit blurry on it. But here, instead of just counting order ID, which may appear more than once, counting that distinct order ID, right? So that one order ID, it may have multiple order details, right? As it was probably giving me those extra rows, right? It may have multiple order details, like for each item used in that order, or each item bought in that order. But I don't want to count each and every one of those order IDs, right? I want to count the distinct ones, like um, just the entire order, right? Because that's what I'm concerned with here, right? The total quantity for that one order, and that total quantity comes from all those different order details. So the aggregate I'm using is count and sum. So first I'm counting all these order IDs, kind of respective to customer ID, and I'm using this other aggregate sum to just count up the quantity of all those quantities associated with that order ID, right? Or not really associated with that order ID, but the quantity of orders associated with the customer ID. I don't know if I explained that one too well, but definitely spent a lot of time mulling this one over. Um, yeah, using that group by, because we're using a aggregate on rows with that constant field customer ID, right? So return customers. Okay, 21 minutes. We'll try to wrap this up soon here. Let's see which ones are the best ones I try to explain. Okay, return customers in the order, including customers who place no orders. So once I heard place no orders, I immediately thought left outer join. So it's kind of why I'm using that one right there. Aliasing. Here, more of a simple one. Just combining these two tables based on the customer ID. So get the customer and his order, right? And just give me back the order ID, order date from that, right? But we're not using inner join here, so we include customers who haven't even placed an order. So it would preserve those. And if I scroll all the way down, oh yeah, I won't scroll all the way down, but you see the difference between the two is 832 versus 830. This is along the same lines, but I'm just extracting specifically those null customers. 6, return customer with orders placed on. Okay, so this one, yeah, it wasn't too bad. Yeah, so I'm just doing an inner join. I'm combining that customer and order table. Give me the customer and his order, right? And I only want the customers who placed an order on this date, right? So I could have did this a little bit tricky. I could have just did order date equals the string value right here, but I wanted to be a little cool and try out date difference. But yeah, that's just the only reason I use that there. So if it's the same date, give it back to me. Yeah. So moving on. So these are, yeah, I could probably explain these pretty quickly. Ready query that returns all customers in the output, but matches them with their respective orders only if they were placed on February 12th. I was a little bit hazy on the wording, but once I saw the desired output, it kind of explained things to me. So I saw these nulls, immediately thought left outer join. So essentially the same thing. I initially tried where. I just had on this, and I tried where, which leads me to the next one, but obviously that one didn't work. So yeah, I put it inside of this class, so I combine these two. So I only want those, I only want to combine it, right? I want to left outer join, combine these two, right? Where the customer ID, where they're linked with that customer ID, right? The order and the customer. But they may not have ordered anything, so it may be null, right? So, so even this guy right here may be null, right? But it's still gonna preserve those and give it back to me, right? But the difference, right, of why number 8 would be wrong is because if I'm using it in here, kind of it's not preserved, right? I'm only gonna get back order dates placed on this date and orders that were never placed at all, right? Never in general. A customer who's never placed an order, absolutely in general, right? So that's why this one is wrong. But return all customers, and for each return a yes or no value. So putting in something of our own, immediately dot case expression, depending on whether. So I kind of just, so for 7, 8, and 9, I kind of reused all similar code. Might have changed it here and there, but yeah, you could kind of see mostly similar code. The only thing here that's different is this case expression, right? So we're having a case expression for this new row right here, has order on 2016-02-12, right? And the case clause just goes like this. So whenever the order date is not null, right? So for orders, so as we just got, so I reused the code from number 7, which gives me this table right here then with the null values. So we can kind of see if they haven't placed an order on that date, those values are null. But yeah, so, brain fart right there, sorry. Yeah, so when it's not null, obviously we do have an order on that date, otherwise it's no. But yeah, pretty simple in that one. Hopefully I did that right. Cutting down the time, we're at 26 minutes this time, but a lot of fun once again. Thanks.